All right. Welcome, folks. So at the end of conditional probability in roulette part 1, I asked the question, are there any independent bets on the roulette board? And my hope is that you all were able to see that there were not any independent bets on the roulette board. We didn't prove it, but we kind of tested a lot of different bets as a class and did not find any that worked. Okay. And then on your roulette project next week, what you're going to be doing is signing up for a variant of roulette. And one of the tasks for your version of roulette is that you need to define some bets on your roulette board, and two of those bets that you define need to be independent of one another. So in the past, students have really struggled with this task. And so I kind of created this video to help bridge the gap. And what I'm going to do is on the original version of roulette, I'm going to show you some different ways that you can come up with bets that are independent with one another. And the way we're going to do this is we're actually going to make up a bet that doesn't actually exist on the roulette board. Okay, we're going to make up our own bet. Okay, so here are the bets. The first one is the made up one, 1 through 19. If you went to the casino, they wouldn't actually let you do this bet. There's a 1 through 18. There's a 19 through 36. But there's no bet that just lets you bet on 19 numbers like that. And then the second bet is a real bet, a bet that we should all know. It's the split bet. We're going to bet on 1 and 2. Okay, so let's calculate the probability of winning our new bet, the 1 through 19. We should start by drawing our numbers on the board, and we can see that there are 19 numbers on the board for this bet. So then our probability of winning this bet is going to be 19 out of 38, which happens to reduce to 1/2. For the second bet, the split bet, we're betting on 1 and 2. So then that's 2 numbers out of 38. And this happens to reduce to 1/19. Now let's calculate our conditional probabilities. So to do that, we need to take a look at the overlap between our two bets. So now I've plotted both bets. And we can see that if 1 or 2 comes up, we're going to win both of our bets. So this is 2. And then remember that with conditional probabilities, you take your given event, so in this case B, because that comes after the bar, and we see that there's 2 ways to win bet B, so 2 out of 2, which simplifies to 1. So really, if you win bet B, there's a 100% chance that you'll win bet A. Now let's do the other way. Let's do the probability of bet B given A. And so again, we need to look at our overlap, which is still 2. And given bet A, so there are 19 ways to win bet A. So this is 2 out of 19, which doesn't simplify. All right, now let's answer the question. Are our bets independent or dependent? So we need to look at these two bets. Well, we can see the probability of winning bet A is 1/2, but the probability of winning bet A given that you won bet B is 1. So those probabilities are different. Similarly, if we look at the probability of bet B and the probability of bet B given A, those probabilities are different. So what that tells us is these bets are dependent. Well, I thought we were looking for independent bets. Why did I show you this? The reason why I showed you this is because I want to show you that it, number one, depends upon what kinds of bets you're using, but it also depends upon how those two bets overlap. So let's change how our bets overlap and show how, in doing so, we can make two bets that are independent. Okay, so we're going to again use this made up 1 through 19 bet. But now we're going to make a second bet, our second bet, the split bet. We're going to have that be on numbers 17 and 20. Okay, so 1 through 19, That's still going to be a 19 out of 38 chance of winning that one. And so that'll give us a 1/2 probability of winning. 17 through 20, that's still a split bet, so you're still betting on two numbers. So this probability is going to be 2 out of 38, which simplifies to 1/19. And then let's calculate our conditional probability. So now we need to look for our overlap. Well, what you should notice is now I've changed the overlap so that they're overlapping on only one number instead of two. So that just happened as a result of how I set the split bet. And so what that means is my numerator is 1, but my denominator is still going to be 2 because there's 2 ways to win bet B. Oh, yeah, I meant to highlight that. Okay. And so then that's just equal to 1/2. What about if we do it the other way? Well, the intersection is still 1. That's our overlap. And there's still going to be 19 ways to win bet A. So 1 out of 19 equals 1 out of 19. Well, now we should notice that something interesting happened. The probability of winning bet A is equal to the probability of winning bet A given that we won bet B. And the probability of winning bet B is equal to the probability of winning bet B given that we won bet A. So we can say something here. We can say that these bets are independent. Okay, so that just happened by changing the overlap. Let's change the overlap again and show that this will mess up whether the bets are independent or not. So now let's do 1 through 19 and a split 27-30. So 1 through 19, that's the same bet. That's going to be 19 out of 38 or 1/2 probability of winning. 27-30, so now I've moved my region further to the right. So my probability of winning bet B is still going to be 2 out of 38 or 1 out of 19. But now when I look at my intersection, well, these bets don't overlap at all. What does that tell me? Well, that should tell me that there are 0 ways to win both bets. They're mutually exclusive. And if your bets are mutually exclusive, right, there's 2 ways to win bet B, so that's my denominator. Well, that means that there is a 0% chance of winning either bet. And so your conditional probability is going to equal 0. Same thing with the other conditional probability because there's still no overlap. So that's 0, this time out of 19. 0 out of 19 equals 0. Well, 1/2 does not equal 0, and 1 out of 19 does not equal 0, so these bets are going to be dependent. Okay, so this was one way to make independent bet in a pair of independent bets in roulette. Let's look at one more example. We're going to again keep bet A at 1 through 19, but now I'm going to make bet B a corner bet, and that corner bet's going to be on 17, 18, 20, and 21. And what I hope this will show you is that this is another way to do an independent bet. Let's take a look at that, and then let's talk about why these bets work. So here, this is again 19 out of 38, which reduces to 1/2. And then my corner bet, remember on the corner bet, you're betting on 4 numbers, so this is going to be 4 out of 48, which reduces to 2/19. And then for my conditional probability, we need to look at the overlap. So I plotted both bets, and I see that there's 2 numbers of overlap. So this is going to be 2 out of 4 ways to win bet B. And so then that's going to equal 1/2. And then we'll do the other conditional probability. So 2 numbers of overlap, So 2 out of 19, which equals 2 out of 19. Well, again, this is another case where some of these probabilities are the same. The probability of winning bet A is the same as the probability of winning bet A given B. And the probability of winning bet B is the same as the probability of winning bet B given A. So these bets are independent. Okay, so hopefully you guys understand now that the overlap is important. How did I know that making bet A 1 through 19 was going to give me some bets that, or that there was going to be some ways to pair bets with the 1 through 19 bets so that the bets worked out to be independent? Well, what it works out to is, I'm just going to kind of give you guys the key here and not really talk too much about why it works. But if we look at this, if we look at our numerators, if I take 19 times 2, that equals 38. And so in that case, if I get the overlap right, my bets will be independent. Here, with the corner bet, it doesn't work out to be 38, but 19 times 4, well, let's calculate that. Let's do 19 times 4, that's 76, which happens to equal 38 times 2. So it's a multiple of 38. So if the number of numbers that you're betting on happens to equal either the total number of numbers on your board or a multiple of the total number of numbers on your board, then if you get the overlap right, you can work it out so that your two bets are independent. In my next video, what I'm going to do is I'm actually going to change the number of numbers on the board because that's what you're going to do in your project. And then I'm going to show you some different ways that you can get bets that work out to be independent. Okay, so hopefully this helps. Let me know if you have any questions.